warm welcome to all of you to this seminar by Division 8 at IVA. My name is Jon Haag and I'm representing the Division 8 Forest Technology Fellows of IVA. And we would like to welcome all of you here on site and also a little bit over 100 people participating online, which is something we learned more and more during the pandemic we've been through. So it's very nice that we can reach out to so many more nowadays. At Division 8, the Forest Technology Fellows of IVA, we have quite many seminars each year, and this spring we have 3 of them. This is the second. The first one was about carbon flows, and it's also a recorded and streamed version, so you can see it afterwards now online if you like to. Today, back to that one later. And the third one, which I do some commercial for now, is on June 20th, which is a global outlook for the wood products industry. So please feel free to register for that one as well. But now to the program of today, digital wood flow, a very interesting and hot topic. And I'm going to show you the program briefly. I'm not going to go through it in detail because we're going to have 2 blocks with brilliant moderators for each block, and it's also the masterminds of this session. And between the 2 blocks, it's going to be a coffee break, and then you can take some coffee or go walking or something, you that are online. But now to the program today. Before we start, I have some necessities to tell you about, and that's mainly for you here at site today. We have toilets. If you miss them, it's just outside the doors to the left of the stairs. And if something should happen, we hope not, you have emergency exits, 3 of them. 1 in those 2 corners and through the main entrance, and they will be very clearly littered if needed. This program should not be something that I talk about, so now I'm going to hand over to one of the masterminds of the program, and it's also the first moderator, Nippe Hylander. Welcome.
Thank you and welcome again. I'm in fact very happy that we have finally, after 2 years of planning, realized this seminar. The pandemic has postponed it a couple of times. I'm also happy in particular to see David Riggenbach from Blumer Lehmann here. And I mention this in particular because that was one of the origins or the 3 cornerstones forming this seminar. It was a visit that we, in an innovation project, visited Switzerland, ETH in Zurich, and Blumer Lehmann and the innovation project was on basically the topic of today, digital wood flow. And the other 2 cornerstones behind this is the project that Mistra has a multi-year program called Digital Forest, and Maria will present some of that. The 3rd cornerstone behind it is new measurements, new technology, in particular the log scanning methodology, which Johan Oja will present. I visited, a few of us visited one of the first installations that came about a couple of years ago. But the fascinating thing now is that digitalization, it has been around for a number of years, but so far in this industry, they have been, so to say, more or less isolated from each sector or each part in the value chain. So much of the material or data or digital data from the forest operations have been thrown away, and then the sawmill starts with their own data producing it, and then they throw them away, and the wood building industry start with their own data. Now we see a great potential in interconnecting these. And that's basically the rationale behind this seminar. So with these few words, I would like to ask my friend and co-organizer Thomas Alsmarker to give a very short introduction of the whole seminar, and then I'll come back with the other speakers in the first block. Thank you.
Thank you very much. Nippe, or is it Bengt? Bengt or Nippe? I'm a little bit unsure about that. I don't know you too well. But
I'll give a comment on that later.
all right. Oh, don't be nervous. Thank you very much for having a short, a few minutes to give some kind of introduction. And the headline is how to achieve maximum value with the minimum impact on climate, on natural resources. And that is, of course, in line with what Gro Harlem Brundtland stated once upon a time in her report, that sustainability is a question of how we can meet the needs of the present without compromising for future generations to achieve their needs. I really like that sentence. I think it summarizes what it's all about. And as you know, it has been during many years a fact that we use much more natural resources than the Mother Earth is able to reproduce. We have a resource depletion. And again, from UN, a report 15, 20 years ago, it stated that quite high figure, about 70% of all greenhouse gas emissions in an average city is directly derived from buildings, and that this requires a radical transformation in how we plan, how we build, and how we operate our buildings in future. And that is, of course, also in direct line with the European Green Deal, how we can achieve, how we can reach climate neutral European continent in 2050. And Ursula von der Leyen also have introduced the new European Bauhaus, which is, as it says on the sentences here, to bring the European Green Deal closer to people's minds and homes. But I would like to emphasize the last sentence, because I also think, I'm convinced that that is what it's all about. We need all creative minds, designers, artists, scientists, architects, and citizens to make the new European Bauhaus a success. We need the integration of different people, different knowledge, different experiences. And that leads us to our a little bit smaller word, so to speak, but that we need a much more better integrated workflow through the entire value chain, from the forest to Wisdom Stockholm, so to speak. How we, in every part of this value chain, can use guarantee that we use the material as efficient as possible, that we pick, so to speak, the right tree for the right product, the right part of the log, for the right product, etc. And how digital tools, various digital tools, can help us, support us to accomplish this. The circular value chain is essential, and we can talk about the circular Green Deal. And circularity is, of course, nothing new. We have worked in a circular manner throughout our history. It's only during the last 100 years that we don't have used the circularity as we have previously. We know this kind of buildings, easy to construct and easy to deconstruct, easy to move and to build up on a new place, leaving perhaps only the foundation left. And all these kind of buildings, they have a circular design in detail. And when the window, for example, is worn out, perhaps and most often it's the lower part of the window. And the window is designed so you can take that part away and replace it with a new one, a better one. And that principle, I think, is very attractive to think in that manner. And now we can look in front of us a new circular era. And we have been thinking in circularity for throughout the history, as I said, and we can get inspired on what we have done in Scandinavia, etc. I'm also very inspired on what the Japanese carpentry can support us with, help us with. And this building is a new kind of circular building system. And I think you, David, recognized the building. It's the Tamedia building in Zurich. And the architect is Shigeru Ban, Japanese architect. And this Japanese carpentry is based on how you can connect different parts in wood, completely in wood, and how you can take them apart again without destroying the material. I have not met Shigeru Ban, but I think that he's trying to do something in that direction and that is possible with new methods, new tools. And then we also can talk about a new industrial craftsmanship. Perhaps we can get into that question a little bit more later this afternoon, and perhaps in our afterward discussion. I also think that the circularity is a driver for modularity, to learn the building industry, what that really is. And I don't think that we are there at the moment. We say that the volume from the house factory is the module, but that's not the case. I think that the more we are looking at the circularity, the more we drive also the understanding of modularity. That building, that villa, that house at the left is done from about 400 CNC milled wooden parts. And it is, the design is, there is a direct line between the architect and the production site. And the modularity, I sometimes do the parallel with Lego. It's the key is to standardize the interfaces between different parts in the wall, for instance. They should always be, the interface should always be the same, and then you can do several combinations to form several wall types. I think that the circularity is a new driver for that way of thinking. Another level is how we use what is already built, how we can add parts above already existing buildings, using lightweight timber structures in different ways, to use timber on top. Used commercial buildings like the one to the left, adding 2-3 stories with apartments as one example. To use an old factory from the mid-19th century, adding a couple of floors, and now we have an office building, a building for the Swedish Environment Protection Agency, as a matter of fact, in Stockholm. And the project to the left is from Umeå, in the northern parts of Sweden. And then we can imagine cities like forest, even though the lower part quite often has a stem, tree trunk, which is not from tree, but from other materials. But above, we can build the tree crown from wood. And we can, of course, also think about buildings like trees. Many buildings you cannot see that they really are from wood. We have the Stockholm Castle, the Royal Castle in Stockholm, not entirely, but mostly made of a timber structure. The Old Town in Stockholm, buildings made out of wood. The wood from the 16th century are still alive, so to speak, in those buildings. And that is also a circular perspective. Perhaps we can think about sawmills like Toyota. That one, yes, I know Toyota is a car maker. And I know that sawmills produce timber, beams, columns, etc. But if we think about a sawmill as a service business, offering the client, the society, the service to transport people from one side of the lake to another side of the lake. In that service, it includes a bridge. And in that bridge includes a lot of timber. But it's not the timber you are selling a service. Who knows what all these changes that we are facing will, what the result will be. But I think really that when we start to move in that circular value chain, that also will give us new business models, new businesses, new way of thinking. And we will not only compete about the lowest price, we will compete about the lowest impact from the entire value chain. Therefore, we need to make this value chain as efficient as possible. And we will have a picture, we will you will have a picture of some of these parts of the value chain today, this afternoon. Thank you very much.
Okay, so with this, I think we will continue with this first block, consisting of 3 parts. One on scanning and identification of logs in the forests, and then we're continuing on to the sawmill, and the third theme is basically around traceability from the forest and all the way on. So let me welcome Maria Nordström from Skogforsk on digital forestry and identifications and scanning and all that. Please. Just to mention, I will bring up all 3 speakers towards the end and then carry on a short discussion between the 3 of you, and then possibly open also for questions from the auditorium. Thank you.
Thank you, Nippe, and thank you, Thomas, for the nice and inspiring introduction to this theme today. My name is Maria Nordström, representing Skogforsk, which is the Forestry Research Institute of Sweden. I am currently the Assistant Program Manager for the Value Chains Research Program, but transferring from next week, actually, to become the Process Manager for the Digitalization process. So with my 2 roles, I hope I'm entitled to have this speech today. It's very nice to be here. As Nippe said from the beginning, we have had some discussion over a year or so ago, when you started to plan this. And I think it's very good that we can be here from the forestry side as well to discuss about the final products, because this is a chain of different actors, and it belongs together. Just a few words about Skogforsk, for those of you who might not be too familiar with us. As I said, we are the Forestry Research Institute of Sweden. We have 4 research programs, as you can see the boxes on top there, ranging from forestry breeding through silviculture, operational systems and value chains. And then we have 2 cross-disciplinary processes, one that deals with societal benefits from forestry and the other one dealing with digitalization issues. We, of course, have a very important part of it to the right here with the research service functions, so dealing with the small plants and everything around that, and giving us researchers help when we have field trials and so on. And at the bottom here, of course, we have a board and CEO, and very important for us are also the advisory groups on all different levels, because since we're a research institute and we work with applied research, it's very important for us to have a good and solid communication with our partners and different organizations that we collaborate with, to make sure that we work with the right questions and that we are relevant. But I was asked to talk about the digital forest. I just wanted to start with the challenges. As Thomas said, we have a few challenges that we need to take care of. But when I think about the Swedish forest sector, I mean, none of you can have missed that there is a discussion around the forest. And I think one of the challenges is of course, the license to operate. If this sector, it's being scrutinized from different parts, and of course we need to make sure that we are sustainable and doing the right thing as good as we can. Currently we have a large focus on alternative forest management regimes, for example. We need to work on ground damages and biodiversity issues and stuff like that. Another challenge that we need to take is, of course, to stay competitive on the global market. These days, it's easier than otherwise, Johan, but but this is a constant challenge that we need to work on, of course. And also to maintain economically sound contractors, of course, because they are the foundation of what we do in the forest. And last but not least, we need to be able to recruit the next generation's workforce. And what I wanted to say with this is that I think that digitalization is not the answer, but I think it's a good tool that we can have great use of when we describe what we do in the forest, when we are efficient and make the best use of this resource, and when we want to attract the workforce that we need to be able to maintain this business. And when you want to look to the future and talk about the future, perhaps you need to take a step back once in a while and just flip through old documents and look at the history and what has actually happened. And I just did that. I read through some conference proceedings from different Skogforsk conferences over the years, just to have an idea of what the development had been in digitalization. And when I went back 26 years, and then I found this nice piece of work saying that we need the same language in the forest and in the sawmill. And that is actually what we are going to talk about today. So this is something that we have thought about many years ago. But of course, the development has gone quite rapidly from here. And at this time, in our conferences, we talked about 3D log measurement technology in sawmills. We had the X-ray technology under development that we will learn more about today. We had older means of communication from the forest. We didn't really talk or give any feedback to the people in the forest, the harvester operators. And we said that we needed more information about the forest, but at that time it was largely manual measurements that we could rely on. And we had the apportionment backing is more a method how we could better tailor the product to the customers. And then 18 years ago, we had this fancy type of phone that we could actually carry around in the forest. But then we had a vision about the 2010 logistics vision. And as you can see, it's the same type of things that we talk about today. At that time, we also started to look at the measurements in the forest, so actually trying to make sure that the quality was good enough. And then we started to think about improved methods for having forecasting what would come out from the forest. And then 13 years ago, we had a conference when we talked about the increasing demand from industries, the LiDAR methods that you will hear more about. So the laser scanning that was coming on a broad basis then. We had Forstand and Stanford. Those are two standards. For the first one is to describe the forest, and the other one is to communicate with forest machines. And that is also very important, as I say, talking the same language. And also, we started to combine the data from these laser scanners with data from harvesters, so from the ground and from the air. And from that, I would argue that today we are in a sort of a perfect storm for forestry digitalization and automation. And why do we say that? Well, we do have a lot of systematically collected data from forest machines, timber trucks, remote sensing technologies, from the air, from the ground. We have a lot of field measurements with accurate positioning of each tree. We have a lot of images from different satellites or other sources, and also advanced industry measurements, so a lot of data that we could use. As I mentioned, we have some standards, which is very important as well. We have different techniques or data management methods, cloud-based, different types of databases, digital twins and whatever, and those can help us handle all these data. And last but not least, of course, the artificial intelligence and machine learning and all of that. So we have a lot of tools that we could use to improve on this using digitalization. Good. I just wanted to give some examples on what we work on and what you can use in terms of field measurements. We still rely on a lot of manual measurements, but there are other tools as well that you could use. These are just examples. So 2 examples of more cell phone applications that you could use, stream video and then measure trees, or AR techniques in cell phones. The picture in the middle is from SLU, where they use terrestrial laser scanning to, in great detail, describe the forest around it. And the last one should be moving if I do like this. This is a project where we also participate, where they use drones to fly beneath the canopy, and they try to measure the forest by that. So all sorts of different technologies that we can use also to describe the forest. And of course, the nationwide LiDAR campaigns is a very important data source. This is the coverage in beginning of February of the second LiDAR campaign. So this is quite high resolution, and you can use it to describe the forest. Those are just some examples. At the top there, you can see, of course, you can measure tree heights, which is laser is very good at that. You can estimate forest volume, the basal area, and so on. You can also, as the example to the right here, describe the growth of the forest if you have data from different time periods. So this is a very good data source for us to, in large scale, describe the forest in greater detail. And this is something that we work a lot on at Skogforsk. So collecting all types of data from the value chain. So starting in the forest, describing the standing trees, and then using the harvesters, so the forest machines, which are standardized, the data from that, and the information from trucks, and then finally from industry, and just collecting those types of data together in a database and creating different types of tools to handle the data and try to make use of the information. And I just wanted to give one example on on the traceability. So this is a harvesting object. The data is from the harvester. The square here, the red dots, or the dots are the position of the harvester where each tree was harvested. And as you can see, you can make a map of where the harvester has gone in this object, and from this information you can describe for each tree. Of course, you can describe the number of logs and stuff like that, but you can describe which tree species you have, how large this tree is, how high the height of it, and we can also calculate the age if you haven't measured that. So you can describe the forest like this from the harvester information. And this is just an example. So in this case, you can also break down this information. So we had a timber class in this case between 30 and 32 centimeters. And the logs that you can see, they are within these rings. You can see that we had 15 logs in this example from this timber class. We can also see what log type it is, if it's the first, the butt log, or if it's the second log. And then we could use that information, of course, later on. When they arrive to one sawmill, we can see if we can have a match. And I would argue that on a harvesting object level, this is all fine. For a certain timber class, we can also describe most of the logs and find them in the sawmill. For the individuals, well, some, we can identify some, of course, if they haven't too many that are very similar. But we can describe these logs in greater detail. And then I just wanted to give you some example on what we can use this information for. We have worked quite a lot with information that we think could be useful to strengthen the forest industry interface with what we call digital property declaration. And this comes from, this is a map that shows the different density of spruce timber in different parts of Sweden. And in this project, we work on calculating, in this case, density, for example, from the information from the harvester, and if we know the age of the stand. And then we can estimate what type of qualities or properties that will come out from this harvesting object. So in this case, it's illustrated over here. So this information is actually from from the sawmill. So they have scanned and sorted this timber into different qualities that they use for their products. So with the model that we have created, we can forecast the share of, for example, quality D or something for a different harvesting object. So trying to illustrate like this. So all the bars here are different harvesting objects, and as you can see, they have different shares of the different qualities. So in this case, we are able to say at this delivery will have this specific share of different qualities, which will perhaps or hopefully make life a bit easier for Johan and his colleagues at the sawmill if they know better what will come in, and then they can plan their production according to that. Or the other way around, that they tell the forest what they want to produce, and then the forest can adapt to deliver the right type of timber for that plan. Summarizing then, so that is something that we work on right now, just a few snapshots of what I think could be on more the operational horizon quite soon. Higher resolution LiDAR, it's discussed what will be used next time you have this national coverage. And SLU and other research organizations, they work a lot with very high resolution LiDAR technologies to see what we can use there. So you can see you can identify single trees. That is something that is coming. We have worked together with harvester manufacturers and a few companies to be able to position the individual trees using a harvester. And this is actually something that will be available quite soon, which will be very good, because then you can say that this tree has been harvested from this position within plus minus half a meter or so, and then you can match that to the LiDAR information. This will be available in standardized production files. Very handy, I think. And then also what connects to what the other people will talk about later, I think that we can use AI and machine learning to connect these different data sources from the forest and the forest industry to learn more on how we can improve the value recovery. And last but not least, different platforms for sharing data so that we don't keep the information in the forest or the forest industry or somewhere else, but that we share it so that we can improve as a whole. My last slide. I was thinking about what could be the keys to success. These are some thoughts that I had. I think a big key for success is access to big standardized data. As I told you, this is what we have, and it's very, very useful. The infrastructure for taking care of this information is almost in place. We are still working on it, but I mean, we have the national coverage for the LiDAR data. We have all the harvesters working on the same standardized format. We have a lot of databases. So we are in good shape. Connectivity, this is an issue. When I started at Skogforsk, I don't know if any of you remember this Net 1 or the ice net that they used in northern Sweden just to try to get information out of the forest on another bandwidth. But that is gone because now the mobile coverage is good enough so that we can send a lot of information from the forest. So that is a very good thing. Quality assurance of measurements so that we can trust the information and the data that we collect. Biometria, not to forget, because what we have in Sweden, we have a common IT hub with Biometria, which not many other countries have, which is a very good thing for us. Collaboration, of course. We, Skogforsk, cannot make any of these things by ourselves. We need to collaborate with different partners. People, of course. I have a lot of good colleagues at Skogforsk and at my collaboration organization. We need good people that have good ideas. And then some luck. Thank you.
Thank you, Maria, very much. I think one of the crucial words you mentioned here was interconnectivity and connectivity. And I think I will come back to that with a question when all three of you are here, because I think this is one of the crucial issues. You've shown there is an impressive amount of data produced. The crucial thing now is how is this transferred to the next step?
Yes.
And I think we'll come back to that. How can the information, as you mentioned, from the sawmills or downstream be fed back to you to improve your operations? And the crucial word again is, what's the added value of this? Okay, with this, I would like to ask Johan Oja to come to the floor and make your presentation on the CT scanning and the applications of that.
Thank you. So, my name is Johan Oja. My main work is as technical manager at Norra Timber. I also have a part-time as associate professor at Luleå University of Technology in Skellefteå. And as said, I will talk about log scanning and different approaches for increased value yield in sawmills. And going back to what Maria showed you, we have one thing that is sort of defining for our industry. The fact that we have a biological raw material. The fact that every log has its unique properties. And to be able to utilize the raw material as well as possible, we need to have information about these unique properties. The fact that every log is unique also have an implication on the sawmill industry or the wood industry. And that is that our industry is in one way different to most other production industries. Most industries has a convergent flow where they buy components and raw material, put it together to a limited number of products. Sawmills buy logs, and every single log is divided into several products. So we have a divergent flow. The result of this is that a typical sawmill produces a huge amount of products. For instance, at Norra, we cut both pine and spruce on all our sawmills. And if you add together the fact that we have two species, we have maybe 15 different dimensions because we have several customers that want their very specific dimensions. We have actually, I think we drive to at least 6 different moisture contents for different customers. We have 25 different grades we grade the wood into because we also have, the customers also have specific demands for their products, and we have 15 different lengths. Add together this more than 3,000 products, and the fact is that many of these products are not something we want to produce really. It's just a consequence of when we cut the log and we don't know what's inside the log, so we get what we get when we cut it. So we have customers that want these specific combinations of dimension, moisture content, and grade and length. But when we produce it, we also produce some combinations that we don't want, that we don't have a real demand for. So one can question why is it that the sawmills use this strategy? Why is this the most profitable strategy? And first of all, one important thing is the high raw material cost. If you go to a sawmill and you put together all the costs for salaries, for maintenance, for energy, add all this together in one bin, and then you see how much you pay for the logs. So you pay twice as much for the logs as for everything else in the sawmill. So that means that you have to utilize the logs in the best possible way. At the same time, we have a low value of the residual products. If you compare, depending, of course, if it's pulp chips or sawdust, but the difference is maybe 6 to 10 times difference between the residual products and the main products, the products you want to produce. At the same time, we have this biological variation I talked about, where we have unique logs, and we have unique customers with their unique demands. So we have to be able to do this in the best way, we have to try to combine the properties of the unique saw logs with the properties that the customers demand. And to do this, that's the way to get the highest possible value yield. We want to produce the best paid dimensions and lengths, the best paid grades, and we want to produce high volume. So we want really to produce the best products from every log. And of course, if every log is unique, the result is that we have to know really what's inside the log before we cut it, because otherwise we can never fit the properties of these unique logs. If we don't know where we have all these knots and disturbances of the pith like we have here, then we're not able to optimize and find the best customer for this specific log. And the result of this is that if we want to produce really on demand, if we want to cut a log for a specific customer, we can think, why? Of course, we do that to some extent today, but we don't succeed. We produce these more than 3,000 products, that many of those that we don't want, really. The problem is that if we have this hypothetical customer that wants to buy 60 cubic meter of redwood, 50 by 175, unsorted grade, 4.8 meter long. And you can guess, try to guess now, visualize the number. How big volume of logs do we need to cut to produce this? If we just cut saw falling, we do as most sawmills do today. We sort based on dimension and species, and then we cut random logs to produce this. How much do we need to cut? We need to cut 6,300 cubic meters of logs, because it's only 2/3 of the log that become centerboards, and then it's maybe 15% unsorted grade, 15% 4.8 meter long. So it's only 1% that actually becomes what we aim at, or what this customer asks for. If, on the other hand, we have a scanner, an X-ray scanner, or even better, as I write here, a CT scanner, so we really know what the log looks like inside, what properties we have, so you can choose the right logs for this customer. Then we only need to cut 200 cubic meters, because still 1/3 is centerboards, but 90% have the correct combination of grade and length. And then we have 30% instead of 1% that fits the customer needs. And then we start to get closer to something we can to produce on demand to a specific customer. So what I think to increase the value yield in a sawmill is that if we go from the strategy we have without a really good knowledge about the log, then what we do at that stage is that we try to find a customer for each board that we produce. And what I think is to really increase the profitability of the sawmills, we have to go to a strategy where we actually try to find the right logs for each customer. But that also needs that we have to be able to know what's inside the log, to really match the properties of the log with the properties of the customer. And then Petri will talk more about the traceability in the next step. But I just wanted to mention this because the fact that every log is unique is also a possibility, because the unique properties, the unique position of every knot inside this log creates a unique fingerprint that we can use to trace the products throughout the whole production chain. And I really think that, as Petri will talk more about, and what Maria also mentioned, the thing to be able to trace information from one step in the process to the next. And I really think that this is also one way that we can increase the profitability in the sawmill industry, because a real process control requires that you have a feedback loop, and without the traceability, we don't really have a feedback within the system. So I think that this is also a key factor. So thank you very much.
Thank you, Johan. I think I will immediately ask Petri to come up to the floor, because you will continue with some other aspects of this possibility, not only from computed tomography. CT scanning is computed tomography, which is basically the same thing that we may end up in the hospital being controlled. But in the sawmill, it goes about 150 times quicker. And that was one of the technical breakthroughs that was awarded the American Waldemar Prize a number of years ago. So that's one of the key things here. So please, Petri.
Thank you, Nippe. Yes, I'm going to talk about my favorite topic, traceability. First, a little of myself. I started with pedagogics. And I started also with some programming as a kid age, and gathered 50 other kids and started a programming group in Borås. Most of those are still programming, but they do it as a job. But I'm still trying to do that. And this background, I would like to point out one of those backgrounds that could be interesting in our industry, is the media industry. I've been working at the Swedish Broadcasting Corporation and a lot of different newspapers. Newspapers, they started their digital era already in the 80s with the desktop publishing. So already in the 90s, we got much of data. So we got that expression, big data, already in the 90s. And big data means also we need workflows. We need a lot of applications, software applications, to make it realistic to publish a newspaper every day or publish some news in the radio. You need also connect, reporters throughout the world, from soccer games, reporting live and sending pictures and all this stuff. So the complexity in media industry is a good background if you are developing this industry today, because today in sawmills and this forest industry we have the same needs as newspapers and media got in 90s. Later on, I got into research by working at RISE, and I attended a project, Digital Sawmill, together with Moelven. And the first thing I was thinking of, okay, so if we are going to digitalize these sawmills, how could we connect data together? Because all my other experience before, you could always connect data together in some way. Article numbers, authors, and so on. And logistics, you have ID numbers on each package or what you would like to trace. But in this industry, there is no fingerprints. There is no IDs. So I started when we started to digitalize, I discovered that you could find traceability by doing some automated data analysis. So I applied for a patent for a fingerprint method that could find data that belongs together to the same log on a transportation belt, where you do a lot of different measurements, and got that patent 2 years ago. I got even more interested, of course, so I started work at Moelven full-time to realize some of those ideas. Since 4 or 5 years ago, we have been trying a lot of different methods for traceability, X-rays and log end surface with cameras. So you can, we have a very exciting project ongoing right now, together with a company called Tigertech, a young, smart men that produce a method for analyze the surface of a log and to identify it later in the production, which is a very cheap method. And also the production pattern method, that is the patent I applied for. So different methods is based on a relationship in data. It's always a relationship. It's all about relationships. I mean, already in the newspaper era, we have relationships, and this is the same thing here. If you have a log, you have relationships to different things that happens with a log. I would like to talk about some challenges here. If we can achieve a full traceability from forest to the end product, then we could have some competitive advantages. We could tell that this product is exactly what you ask for. And we could also achieve that Johan Oja talked about. We should find the logs that the customer actually need in the products. And this also could be achieved by if we have a full traceability. And we could also do a lot more product improvement, because in sawmills we would like to get up the volumes because the market is very good now. So we have we need to have a better availability in our process, and that could be also improved if you have a good traceability to keep track on each log and package. The problems that we need to solve in the future is the accuracy of the traceability, because it's not 100%. It's something like 90 to 100%. Any method you check out, it is not 100%. And there is data missing. Our suppliers of equipment, they deliver good products, but when you start to analyze the data, you see you don't get all the data, and sometimes they miss some logs, and sometimes you get bad information, like null values in the measurements. And the measurement uncertainty, when I was at RISE, I was working at the measurement technology, where they do the research on our measurement methods. If you see that you have 23 millimeters on the display, do you really believe that it's 23 millimeters? If you check it out, it is not. Sometimes it's not even close. So we have a lot to do here to get a better way to calibrate our equipment. So this is only the start, because the values we are measuring, do not trust them, I can tell you. And that therefore also we need competence in this industry, because this is completely new things. We don't even have an organization on most sawmills to fix this. When we talk about calibration, for instance, of digital measurements, who can do that? Not even the suppliers can do that sometimes for us. Also, when we fix all these things, we can also think of where should we store the data. I mean, for a sawmill, it's not a problem. We can always find a server and store the data there. But if we want to cooperate along the value chain, how do we share the data between the partners in the value chain? Is it a government authority, or is it Biometria that should collect all the data? Or should we work like in blockchain? We send always all the data to the next part in the value chain, or how do we do that? And then we also talk a lot of standardization. I know there is a lot of research projects that is working with standardization of the data and how we do work with digital data. Let's talk about that a little bit more. I mean, this is a typical schema over a sawmill, where do we have a log sort, we have a saw line, and drying and dry sort. And for us, we use different methods here. We have an X-ray in the log sort. We could put that same X-ray on the saw line, because it's a very expensive equipment. But if we put on the saw line, then we can't do a smarter log sorting. And if we put in the log sort, then we do not really have today a traceability to use that X-ray image to make a better rotation into the saw line, for instance. What we have our shoes, it's very expensive technology today. But you can collect and you can analyze and you can make some relationship and get out a lot of data still, and you can also store it somewhere. But think of who should be the data carrier in the end. This is a more complex view of the same thing. We have tried to write all the systems that collects data in the line here below the process in the middle here. This is the line where we collect from all the systems. And then we have a structure integration, and that is a really good advice for you. If you're going to collect data, have a good structure for integrations. Because if you put software a lot on several different places and let them do their jobs to collect data, it will be complex. So use a structure and a central place for integrations. And back to the standardization, as I talked about. I think it's utopia to standardize this industry. So don't even think of it. And do we need to standardize this industry, really? I mean, by using a structure integration, we could fix all these differences between the suppliers. So this is an example of the sawmill in the middle, there where we collect the data, the database. And we have two different suppliers, A and B here. So if supplier A delivers some data in some format that is not compatible with the format with the supplier B, we can fix that with a good integration structure. So we equal the data like different timestamp methods and units that is tenth of millimeters or millimeters. We could equal that data. So it's not a problem. So we do not need to standardize. They don't need to be equal. They could actually be whatever format, as long as they keep the same format over time. That is more important. So also in this picture, I want to talk about many suppliers today. They try to produce very fancy graphical user interfaces. They put a lot of time on that, so they can draw a lot of beautiful diagrams. So every time you buy a new product to a sawmill, you get 1 or 2 monitors. So if you have 20 different products, imagine you have 20, 30, 40 screens. It's like a wallpaper of screens. Have you been at a sawmill? Then you can see some of the operators, they are looking at 20, 30 screens every day. It's not good for an operator to have so much information in different screens. So what I mean is that for the suppliers of equipment to sawmills, just deliver data so it can be integrated. And I think today we can pick the data and visualize it ourselves. And we have done this a lot of times and tried it, and you can collect, different suppliers' data into one screen, and even collect some relationship between the data to see how it is connected together. And integrations, you have the transformations, you can equal data, and you can get a structure that is much better than anything else, and it simplifies also troubleshooting. So in a process, it could look like this. We have the process, and we have different suppliers. They just deliver data, and that's why I call it a passive cooperation between suppliers, because the suppliers do not even know that they are cooperating, because their data are stored in the database, and we do things by adding these two different suppliers' data together, and that's a passive cooperation. So we don't need to standardize or even cooperate between the suppliers. Just deliver data, and we, as a customer, will fix the presentation of it. And if we go from a forest to the end product, like home, was Thomas, I think you were talking about using modularity. I was thinking, my home is a log house. Maybe that is a way of living in a modular house today. If we collect the data, it could be like this, that like a blockchain techniques, that we use our methods, because we have a lot of methods today, to make these relationships between different vendors' data. So from the forest, you get the data, and you will find the relationships and put it together with the sawmill data that will be added to the blockchain package. And like in glulam or wood or component, if they do their measurements, they first get all the data from behind, from the previous parts of the process, and then add that data. And I have been working with methods for doing this. So if you are more interested into details, because I don't have the time to tell everything here, so you can be in contact with me. I can tell you more about this in detail. But the methods is there, and you can do it today, but it's not realized yet. And it's also possible in this vision to give feedback all over the value chain. Because at the sawmill, we do need to know that our products really fills the requirements. Some of the traceability in a sawmill, it's not on individual level because of the limitations of the traceability still, but we have a possibility to do some individual traceability. But you can also rely on the package level, which is the second row with the R's, so where you have a population of individuals. And by do analysis, you can walk over the value chain by sometimes being in an individual level to a package level to an order level, and it's good enough. And you can, in this picture, also deliver by this technology a digital process declaration that could be used later in the value chain. And the content of the exchange of data could be like this. We have a project called Bassa Jaun. Have you maybe heard of it? And the DVC is another project that we have been active in, where we define more in precise what could be the information that could be valuable for the different parts of the value chain. I will end up here and say kiitos, because I'm from Finland.
Thank you. I think if all three of you could come up here, and we will carry on a short discussion for some 10 minutes around this. It's an impressive amount of data that you have, all three of you lifted up. And as I said, one of the crucial issues is, if I could address Maria first. Now you're saying here that all the scanning actually has made it possible to come up with maybe not fingerprints, but thumbprints. A little less precise than actual fingerprints on the logs. What, if we look 5 years ahead, what kind of data will you be shipping along with the timber truck to the sawmill? That's my question. And of course, if I turn to Johan and say, what of all those data are actually necessary for you to utilize? You're having your CT log anyway, so you will analyze it again. Or is there any interconnection here which improves the processability of the process, the effectiveness of the process, apart from the improvement of the value output? So which one of you wants to come up with a question for respond first?
Doesn't matter. I'm just a bit. It's short, very short coffee breaks on and off here in the background. Anyways, I think that we can start sending information that we do have right now, so we don't need to wait for more information. As I tried to describe with these digital property declarations, it's more not just to say, I will bring you some package, this is the volume, it's more, this is what I expect to be in the package. And we will not be able to describe in great detail each log, but we will be able to describe differences between different deliveries. So just giving you a bit more time to plan on his side, or match with your production plan. I think that will be doable, but we need to agree. Petri argued that we won't need any standards, but I think we need to agree on some common ways of communicating and some formats and stuff. And what do I mean when I say density? Is that the same thing that you need, so that you can read what I send you and understand what it is? Okay.
What's your comment to that? Is that enough, that kind of data information that you get?
Yeah, I think if you look from the flow from the forest to the sawmill, first of all, we'll say, I think it's a first step, and Maria and I discussed earlier that one thing that we, as you said, that one thing we sure know is that we don't know what we will get from this, and I think I think that's correct, that we know that we miss a lot of information, and the only thing we know is that when we will find a lot of new things that we haven't thought of before when we start working together or integrating the data. But I think that it's one first step is really good, because we have the variability between the logs, but we also have between different harvesting areas. And we know that for one specific area we can expect maybe 30% of a certain grade of logs that fits a specific customer, but on next step it's only 15%. And of course, for the production, we will still sort the individual logs based on our scanning when they come to the sawmill. But for the production planner, it's really good to know that, okay, now to know
if it's 15 or 30%.
Yeah, what he can expect to get, because he knows if he will be managed to, will I fill up one kiln with this product or 2 kilns or whatever. So I think to increase the planning, I think getting more data in more ahead is really good.
My second question refers also to what Petri said, is that you showed a red line from the house or the glue lamp factory back to the forest. And this is the crucial question about feedback from production into the forest. And when you get this information, how will you be able to improve the not only scanning but also the actual forest operations? Will you be able in the forest to sort a little bit better so that Johan will know better whether it's 15 or 20 or 30 or 35% of this? I mean, you showed a split of the different qualities, but could you come down to not only I mean, even to on truck delivery level, say, now this is more specified. Is this possible within 5 years?
Yeah, I think so. But it's, as always, it's a matter of costs and benefits. So, and digitalization would not come for free, even if we would like it to do it. So I think we need to make wise decisions which horses we should bet on in this race and find the most useful ones that we start working with.
I think, yeah.
But what you mentioned with the feedback, I think that's crucial. So and that's the whole idea about speaking together, not just working in the forest and the forest industry and making up the same wheel on different places, but just having feedback. And that's with those. I had an example with the machine learning and AI models. If we can have that, we can improve the models to customize the timber for one sawmill or another sawmill or a pulp mill or whatever. So I think that's very useful. But then we need to be able to tie it together and with the traceability that we don't really have full on today.
Yeah, I think the traceability is the thing. This fingerprint is more than only, so to say, fingerprint on quality. It's a traceability from the customer to know whether it's certified produced timber, etc. I think we're all, you mentioned costs and benefits. I think we're all preoccupied by costs, but we're rather diffuse when we talk about what's the potential value and the benefits of this. Do you have any comment on that? What would be the higher values if you got a better information from the deliveries, not only on package level?
Do you mean from the forest to?
If you get from the forest.
To be honest, on this day, I think we are too early to use that data from the forest. So our focus has been to fix the sawmills, because you know the availability at sawmills is, I mean, it's 60-70%. The rest is the different stops. So we have to fix that first. It's so many manual steps in the not so much automation. So I think if we fix that first, so it's more automation, and we have a process development that gives us higher rates of availability, then I think we could have used maybe of those
the fingerprints.
Yeah, from the forest. Okay. I think along the value chain we have more use of to deliver a fingerprint and have a traceability to the next level, like a glue lamp, so they get their products that they need, and they can do their products in their place.
You're really preparing for the next block.
Yes, and also a comment. Of course, I also like standards, but you know, human works. Everybody have their own standard, and I think if we wait for a standardization, we will not get there. In soon. I think we need to start before that, and we can do that because we can always share our data, and if it's different formats and different units, it can be fixed, and we realize that because our suppliers and the equipment delivers very different formats, and it's not a problem for us because we equalize that, and I think that could be also be done over the value chain.
Okay. Do you have any comment on that?
No, I think it's correct. I think there's a great potential in not only, I mean, as you say, with the productivity, also that a lot of it's good to feed back information to the forest and also to the customer, but there's a great potential within the sawmill, and that's when we're looking in investing now. I think that we look at the traceability to the forest and the customer as potential benefits, but we will gain what we're counting on to make money up, make up the investment is internal improvements within the sawmill.
Okay, if I sum up from both from you and you're basically saying, for the next 5 years, we will take the low-hanging fruits, and the low-hanging fruits of this is process optimization, availability in the sawmill, marginal production, which is a great big value. But in 5 years, you may come a little bit further with this thumbprint from the forest turned into fingerprints in the sawmill on the different all the lumber produced with individual fingerprints to be used by the next block of this session in the building. So
okay, just before the second block starts, I would like to say a special thank you to Johan Oja, because he has to leave us the session before it has ended. He told me he had to rush back to the computer tomography scanner. So, thank you very much, Johan, for this.
Thank you.
And then
Thank you very much.
And then I can't help ask you a question which I'll have one very short answer to. You mentioned to us when we were up looking at your newly installed CT scanner that the increased value output that you got in this 300,000 cubic meters sawmill was something like 3-4% in value output due to the CT scanner, and still you haven't used the fingerprints yet. What do you expect to get in value, increased value 5 years from now?
We can put it like this, at least, that we are in both Skåge and Säva, we are building new log sortings where we will put CT scanners in the log sorting to get the full, to create the fingerprint, because we really think that it's worthwhile. We will make money from it. So
3-4% will be 5? Increased value?
I won't be able to say. It's really difficult, but we're quite confident that we will
okay.
make money.
Good enough answer.
Thank you very much.
Now we'll see if you can hear me. Yes, perfect. Welcome back. And I will give you a warm welcome to you, Anna. You will talk about Cederhusen. You will talk about, I think, about how digital method can support more climate-effective working progress.
Yes.
And you are the operating manager at Folkhem.
Yes.
A warm welcome.
Thank you very much. Hello, everybody. I'm here as to represent the last part in the value chain from the forest to the completed building. So I'm very excited to be invited here. And Folkhem is actually, it was founded already in the 60s, but 2012 we decided only to work with wood constructions, and we are a housing developer. And today we have a portfolio containing 13 different projects, which are all going to be built in wood. And the reason for us to work with timber and wood and the whole question that we discuss here is because of the climate effect of shifting from concrete and steel towards wood structures. And that we understood already 2012, and since that's the main reason for us, we have to also prove it within our projects. And we see the big possibilities we have within all these different kind of projects that we have, to sort of be a part of the solution more than the problem. And we have a culture that we make all the projects we have accessible for research and development from all different kind of experts. And today we are constructing the first block out of 2 in this project, the cedar houses. It's the most complicated and the biggest project that we have. And we have been sort of developing this culture of how our own working progress will be, very much from this, what I'm going to tell you about from this question. And it all started with a collaboration between Folkhem, Syncabim, and the Swedish Wood, and also Bjerking. They made a report. They helped us to connect the digital model with a software program, One-Click LCA. And we wanted to investigate how can we work in order to get the material in a very early stage, in order to make the right decision in the projects to decrease the climate footprint of the projects. And it was, of course, connected to the carbon dioxide footprint of the project. So it's we learned the super important thing that we have to have very what was the word? Digital accuracy. Yeah, we have to work like very specific with our model in order to make this happen. And another thing that we learned was also the true value for us connected to very specific data, connected to the actual products and the materials that we use in our buildings. Because we compared 4 different suppliers of exactly the same product, CLT boards, and this was the output from the LCA calculation. And the biggest difference came from the suppliers that didn't have EPDs and the one that had. So, and the other difference was like the 2 first one. There was one was placed in Sweden and one was in Germany. So that was the transport and the energy supply for the industry. So that was like a great lesson for us to understand. Like it's so in the next stage, because we are delivering the LCA calculations to the municipality, and that this is the proof for us to tell them, okay, we are the tools for you to sort of meet your goals regarding the climate shift. So this was a starting point for a collaboration group that we started. We had this the first ongoing turnkey contract for the first block, and we had procured material suppliers, and the purpose was to sort of take this question a bit ahead, and we wanted to meet the aim for have a quality assured climate calculation. And we wanted to see the connection between that, and also we saw the same tool for streamlining the construction process, which is for us, is a big question, because we lose so much money in that phase, and it also affects the quality of what we actually stand with in the end of the project. So we created this group. It was us, it was like all these parties, and it was not financed by anyone. It was just driven by like a common interest of improving. And what we did was we looked at the existing processes. We saw that, okay, we have the reality here. It's an ongoing construction site, and we have all these suppliers, and we have a contractor that was like building it. And we looked at what are the challenges with the current working model. And then we also saw at what is actually happening within this field. What's the work now connected to standardized processes and standardized digital process support in order to get a glimpse of what's the low-hanging fruits here and how can we improve very fast. And it's quite obvious for us that, like, as a developer, like the biggest value for a very, very long time connected to the projects are the information that we like sort of put into the project all those years before we actually construct it. There are so many years that we develop it and we specify what kind of material, what kind of products, what kind of components are we putting together in order to build this house. And we looked at the work progress and we understood, like, we need to have a way of handling information where we can start with a very, very conceptual phase that's very not so many details, and then to have like a clear chain of where we can like get into details and specify it even more. And then we looked at, okay, but how does it actually look in the reality? Like connected to how many different parties that is actually involved in the project. I mean, it's not one company that is building the whole. It's a whole chain of so many different companies and processes that has to be combined. So what we saw was, like, in the early stage in the project, where we are still owning like the development of all the details, it's quite easy to specify how we should work and what we need and what we want to have. And then in the construction phase, there is so many different parties involved. So, but then in the end, we are still, I mean, the red little man is us, basically. So we are very by ourselves in the beginning and also in the end. So we are actually the part that is supposed to, we have to be responsible for what the outcome is. And we have to tell the municipality that we are so secure of everything that's actually being built within this building. And within this collaboration group, we had different suppliers of elements, components, and material. And this is an example of how the process looks like from when a supplier they get a question from the builder, like, how much does this cost? And then the whole process of like placing the order, like getting the transportation and all the way back to the construction site. And this is just, it's not, you don't have to understand it in detail. It's just a very clear image of all these like different channels of communication that goes back and forth within. So we had a look at, I mean, the first images was like from our perspective, like how does our processes look like? And then the previous image was like, okay, but how is the suppliers and the reality sort of meets our demands? And the analysis of the whole exercise that we made, it was 10 meetings over a year, basically. And we sort of invented like the whole chain of processes within all these different parties. And the analysis was that everybody is very, very skilled within their own processes. As you told us, like, it's so impressive to look at all these, like, how you deal with your, okay, this is from the log, we take it to the factory, and then we have like very, very good control of everything that we do. But basically the problem is when there is someone else actually like taking the next step within the project. What was the relay race that we have within the project? So, I mean, basically, as a developer, we have a very optimized process regarding like how to develop drawings, the technical specifications, and so on, and the digital model. And then when we buy a contractor, there is a big information gap, basically, because we sort of have all this information and we give it to them, and we tell them, okay, now you are responsible, and they have their own optimized process to do this. So this was very good for us to get our eyes on, because we understand that basically the green star is the most important key factor for us, according to this digital sort of workflow, is that we have to be very, very specific of what kind of information we want back from the contractor when the building is actually standing there. And what we want is a true like digital twin that we can trust really mirror everything that's built in. And with a good traceability, of course. So now the first block is completed mostly. And the fantastic thing with this project is that we have 2 blocks. So what we did was to take all the lesson learned, like all the analysis from the first one, and sort of twist the demands when we were finding a contractor for the next block. So we have been specifying we have been trying to specify what kind of information we want back in order to make the whole value chain, they have to improve, like to be very specific and clear of what kind of digital data do they actually present according to what they are delivering. And the whole collaboration group, that was like a step 1 in a collaboration, basically. So now we have a research project connected to this project called Cirkla, which is a big project coming from the government, is financed, and it's called 4 Steps to Getin, which is like I don't know if you are familiar with that, but it's a little key factor of how we can start to give like all different components and what do you say? Within this whole chain, a unique identity, basically. And the purpose is to create a common language that can sort of live through all these different gaps. And it's a decision made on a European level that this standard is actually, it's going to happen. So now we are just learning how to actually start using it. Yeah. And this is, of course, like the whole, if we want to talk about circularity and reuse, we have to start with having like a very, like we have to know what's actually being built in the end, from A to yeah. And yeah, I think it's fantastic. Like the whole wood industry and what we are actually doing has a very, very good possibility of driving this kind of development within the whole industry. Thank you.
Thank you very much, Anna. And now you have shown us a glimpse of what digital methods can do for supporting us in to reduce the climate impact, but also to increase the integration between different phases, different categories of people.
Yes.
We come back to that, hopefully in a short discussion at the end. And now I welcome you, Jonas Runberger. You are professor at Chalmers, ACE, Architecture and Civil Engineering.
Yes.
That was correct.
That was correct.
Yes. And you are also head of D-Search at White Architects. And you will tell us about how digital methods can be used to support recycling, to use and to reuse, but also how digital methods can be used to support creativity.
That's nicely put.
Yes,
yeah.
I hope
Thank
so.
you.
And that's to put some pressure on you.
Yes,
yes, of course.
Thank you.
The floor is yours.
Thank you, Thomas. So I'm an architect by training, so obviously what I'm talking about now will be from a design perspective in a sense. And I think I will try to follow up some leads, but in essence what I will talk about is when there are glitches in the system, when things don't work, can we still resolve something through managing data and systematize that, maybe automate it. So while I definitely agree on everything said so far, my team called Research at White works in these gaps where it doesn't work yet. And we work at many different stages, from concept design to design development, later stage, often design for manufacturing, looking at alternate way of producing things, and also a field we call spatial analytics, which ranges from the urban scale to analyze urban context, early stage projects, to interiors, etc. But I will go straight into this and try to explain a notion that we've been developing, which we called digital design systems. And we see this as a way to, in these gaps and glitches where maybe there is not a ready-made process, maybe the standards are not there, we still try to, within the context of a project, develop new processes, workflows that allows us to manage data in different ways. And we do this by linking the modeling environments with kind of a programming platform, so we can develop automation in different ways. We do this to target specific tasks in these greater workflows, and of course to fit into the bigger picture of the project. So we don't want to make things problematic, we want to make them well-functioning. And the way we do that is by working very, very fast and iteratively to come up with solutions of workflows that fits into the bigger picture of a project. And I'll try to explain this through 2 projects. And as it happens, the first one was part of a research project where we actually collaborated with Bloomer Lehman. So that's an interesting connection in a bigger research project. But it's a bridge project that's still underway. We still hope for it to happen in southern Stockholm. And it's part of a bigger development of housing projects where I believe you are also there, Anna. But our team worked on this little bridge here, which is literally the connection between this new residential area, a beautiful park, and an upper natural area. And just to set this context, it has this weird form, not because of our creativity in a sense, but because it has to be accessible and bridge quite big elevation changes across a road, railroad, etc. So when encountering this situation, the first thing we, like any architect, we went on site, and as it happens, this loop the bridge needs to take to have a quite low slope passes through a protected wooden area. So this is kind of the flip side of the issue of the timber industry. I mean, we scanned this area just to know that we didn't need to take down any trees because there are oak trees here. So that has nothing to do with the production of this bridge, but literally part of the design process. And we, at this very early stage, we worked together with our engineer and advice from Bloomer Lehman out a structural system for the bridge. And we started to identify what are these aspects that we need to relate with each other. And basically, on one hand, we have the situation with protected oak trees, and we still want to draw that bridge through. We have accessibility, we need to have 5% slope, and we have a structural system which is fairly advanced due to the shape and also, in this case, creativity. It was originally meant to be a concrete bridge, but through this process, we pushed it to timber. So these systems we developed allow us then to iterate and to test many different solutions to come up with a specific footprint of the bridge, let's say, that works, and at the same time iterate between an analytical model that checks out the curvature in each layer of the glulam and minimize curving elements. And we believe that we reduce the cost for making the glulam by 40% through that step. And in essence, this process was kind of interesting because it was an early concept study for a bridge, but at the same time, it kind of divided into a research strand and a project delivery. So our researcher, Tom Svilands from CITA at the Art Academy in Copenhagen, worked out a more extreme version of this, where everything was checked and really looked at the boundaries of the material, also by material prototyping and testing parts of one version of the bridge, while and also set in context, while we also then delivered the proposal for the bridge, which is currently still in planning. As far as I know, it may still happen, and we hope for that. Very near another timber building, which is very beautiful. And the second fast example I wanted to show then deals with reuse. And this is again, this is not a live project, it's an initiative coming from an opportunity we had at White Architecture to reuse the timber beams, the oak beams of an old lumber yard in Järvsö, which coincided with a planned event. But the key thing here is that we saw this as an opportunity to experiment. How can we deal with these factors in terms of structural timber for reuse? Obviously in a building which didn't have to be up to code and so on. And the key thing here was that we didn't know the exact quality of these beams until 2 days before construction. So in order to do this, on one hand, the design team worked out through many iterations a design concept, fairly simple, but still open to some variation. And this small concept model was, of course, also modeled in a parametric setup digitally, allowing it to be deformed in different ways, with all joints and details, all timber preset before the final form was set. And then this model was connected to a material library, which was the expected amount of timber beams that we could get. But we didn't know, so we can change this library until very, very late. So this is just our own mappings of what a design system for this purposes would work out. One of the core things is this, we call the matching algorithm, which matches a design model against this library. And it does so repeatedly, of course. So at any given moment, it provides feedback back into a design interface. On one hand, sort of an online version where you could manipulate quite freely, but also experience it through a VR setup for the spatial qualities. And then eventually, once that final setup is achieved, you get the production documentation more or less automated and so on. So this is the setup when it doesn't work. This is missing material. You get direct feedback on this does not work. And once you get it all lights green, you also have IDs for each and every element, of course. Then immediately used, this is the sort of relation between the model, design model and the library. And then on-site fabrication. I mean, this is a very small project, obviously. It's not a building, or, well, I would say it's a building, but it doesn't have all the complexity. But it did carry its sort of providing its value as well. First in a festival, Stockholm office, moving again to Uppsala. And then finally, a couple of months ago, it was finally taken up for transport again, moving it back to Järvsö. So in a way, for us, this has been sort of exploration of technologies and how things work. But in the end, it actually becomes a narrative of timber. And it also has a second name called the 200-year Pavilion, opening next Monday, actually, formally. So my third case, I will not talk about, but just sort of aligning back to some of the things we work on. It's the first time ever I've been being able to touch the projects as I present, because all the wall panels you see here in IVA were actually designed by the same team, following similar logics. Thank you.
Perfect. Thank you very much, Jonas. And now I want to introduce Johan Oskarsson and David Regenbach. Johan Oskarsson from Elling Oskarsson Architecture. Elling Oskarsson Arkitekter.
Yes, that's
you
correct.
might also say. And David from Blom & Lehmann. And we have, during the afternoon, traveled from the forest, and now we are arriving at Wisdom, Stockholm, simply. And you will be our guides on that target. The floor is yours.
Thank you. So, I'm one of the architects. I've been working with this project for 3 years now. And we're very happy to present this today. It's been a fantastic experience so far, and quite extreme project from many aspects. I will start making an introduction to the project, and then I will leave the more interesting details to David. So the Wisdom project is actually a national project. There will be 5 domes built and already built in Sweden in the next coming years. And the one in Stockholm will be built at Tekniska on Djurgården. We were invited in 2019 to do this competition. A couple of years earlier, we worked on another museum project in Lund. This is Skissernas Museum, or the Museum for Artistic Process and Public Art. And it's not just about museum extension. This is a lot about transforming a museum from a quite anonymous museum to a more sort of a public meeting point in Lund. And it has been a true success, and we're very happy to be part of a small piece of it. This is from the inside. It's all about adding social program to this museum. It consists of a condensed program of restaurant, entrance lobby, and shop. So this is the starting point of the Wisdom Stockholm project in 2019. There is a courtyard at Tekniska that you may know of or not, because it's not at all accessible for visitors, not even visually. So today it's really a hidden asset for the museum. And the plot is situated here. It's back to back with the Wallenberghallen, which is an exhibition hall for temporary exhibitions. That was built in the 90s. And the more characteristic building is the Maskinhallen from the 30s. And then we can see the roof of Ridhuset, that is the original old building. Not for the museum, but for the military premises that were here before. So zooming out a bit, we remind us about the fantastic location that this museum has on Djurgården, in the middle of the Royal City National Park. And it's a fantastic situation with the close by water and the nature and recreation, everything. And also now with the new bridge, pedestrian bridge that was built in 2019, it's also very much accessible from the south of Djurgården, which is the more busy part of Djurgården. And the museum has a long-term vision that they say they want the museum to be like an extended living room for everyone all year round. So now the museum is not really using the possibilities for open up to the outdoor spaces and use this unique situation. So since this project, the building itself, is sponsored mainly by Stora Enso, the requirement was to use Stora Enso products and their building systems in CLT and LVL. We previously worked on some elaborated structures with structural engineer Florian Kosche, that is situated in Oslo. This is the first project we did. It's the winning competition proposal for Royal Grand Royal, the Grand Hotel here in Stockholm. A couple of years later, 2018, in collaboration with CF Möller Architects and Florian Kosche again, we won this competition for a new central station in Lund. It's actually more than a bridge over the tracks. It's rather a public plaza, one could say. It's 30 meters wide and 160 meters long, something. And this is very much based on this vaulted theme, which gives the building a very recognizable profile from all sides. You get this vaulted profile from all directions. And it's constructed from a timber lamella roof with the steel columns. So again, back to the courtyard of Tekniska. And to us, this project was very much about adding values also to the museum as a whole, not only to do a cool shape for a particular function, which is the dome function, but also take use of the opportunity to add other values to the museum. And in this case, we wanted to bring in the daylight to a museum that is very dark at the moment, to bring in sight lines, improve the wayfinding and orientation in the building, but of course also to connect to the coming outdoor program and the outdoor spaces of the courtyard and Djurgården in the prolonging. So we started the design process, just examples of different schemes, but we ended up with a quite basic layout in plan, which is more or less a mirror of the Wallenberghallen. It's a rectangular, and the focal point is, of course, the dome theater in the middle. The trees were a boundary, the old linden trees that we wanted to keep. And we also introduced a new link for circulation to Maskinhallen. But in the section, it's a little bit more elaborated. As you can see, it's the dome again, and then we sort of draped softly a light roof that will span the full length of the building, about 50 meters and 25 meters in the short distance. And this was an imagery we did in the competition phase, and it kind of conveys the idea of this living room and the social hub that we think this building is very much has the potential to be in the end. This is a very beautiful made wooden scale model, shows the concept quite well with the projection dome, the white dome, and the outer dome, which is kind of solid CLT timber dome, basically built up like an Eskimo igloo. And then we have this softly shaped double curved timber roof. So the question was, how could we make such a roof in timber by using products from Stora Enso? And we looked back for inspiration and tried to do our research. And we found out about this project that we've seen before but didn't really knew so much about. This is Frei Otto. It's a project from the 1975, and it's called the Multihalle in Manheim. And it's a fantastic grid shell structure made of hemlock, which is a Canadian pine type of species. it's supposed to be a temporary building, but it's actually still stands. And of course, you don't have much of those requirements that we have today for the buildings we are doing, but it's quite fantastic. This is the structure itself. 4 layers of 55 millimeters of battens just joined together with bolts and nuts. So the inspiration from Multihalle we kind of used in the Wisdom project, but instead we were using LVL laths in 4 layers, and then on top of that we had a thicker LVL shell, and everything bound together. And since this is a project that we very much explore the possibilities of building in timber and wood, we also wanted the roof cladding to be in timber or wood. So it's going to be in shingles, wooden shingles. It's challenging in itself, but it's also quite feasible since it's a double curved organic shape to use a small module. It also connects very nicely, we think, with the historic buildings at Djurgården and the character that you could find in that area. So just shortly, this is again the Multihalle and how they were anticipating the forces throughout the structure with this load force strings in the negative shape. And of course we have today a lot better tools. So in the competition phase we did some analysis since this is quite a bold proposal, and we found out that there were some challenges, but it was absolutely realistic to do. So going back again, in the next phase of design development, we were looking for more elaborated, more modern grid shell structures, but not much to be found in the 80s, 90s. So it was all about steel, concrete, and glass. And this is kind of the pinnacle, maybe, for that British Museum by Norman Foster in 2000. But the same year, this pavilion was made by Djurgården. And actually, Fairwater was also part of this project, together with Bureau Happold. And this is a grid shell made of partly timber, it's glulam arches, but it's the main grid shell here is paper tubes. And then there were some following up examples of grid shells in timber. This is the Downland grid shell in England. It's made by fresh oak, so it's a lot more elastic than the dried oak. And another milestone a few years later was the Seville building, and this is a quite large building, fully climatized, with a lot of more hard to achieve requirements. So this is quite interesting project. The grid shell was done in large with wooden blocks in between, but it was a steel ring beam and steel columns. This is from the inside, and the roof is oak, like a screen roof. And then another project caught our eye when we were looking for experiences, and this was or is a project that was completed 2019, the same year that we did the competition, and it's the Swatch headquarters in Switzerland, designed by Djurgården and engineered by Blume Lehmann. And this is a completely different system with prefabrication instead. So every piece is prefabricated into the right shape and size and has a specific position. So in contrary to the other projects where you actually bend the members into place. So totally different idea. And at this point, this was not accessible to us, but it was something that we thought was very interesting. So in the following process, where we had to balance economy, technical, aesthetic point of view, we had some difficulties with the fire requirements. We started to look for alternative concepts, and at some point we were quite desperate and also introduced steel bracing. But in the end, it turned out to be quite interesting shift for a new type of structure, with, one could call it a timber lamella roof system with LVL members, and then there was this still a shell of LVL on top of it. But we still missed this link between the architecture, structural concept, and to the production installation. And at this point, I read an article about Herman Blumer, timber structure engineer that's been part of many of the fantastic projects by Sugarban, worked closely with Blumer Lehmann. And at this point, we were ready to reach out for this. So Herman looked at the project, was intrigued by it, and he took a step back, looking at the original vision we had for the project, and he came up with a proposal, an idea of making pre-bent beam segments of multi-layered LVL boards. David will talk all about this soon. This is just some early, the first prototypes testing the ideas. And the result as it's going to be built is like this. It's quite close to the vision we had. A little bit more coarse, but very much in line. And I will just end with this image, which is a bit strange here, but this is a mock-up that we did for the facade and the roof. And it's almost sitting at the right spot in the courtyard at Tekniska, showing the shingles, showing the solid wood panels for the facade, and the hidden detailing of the glass. So now, David, thank you.
Thanks a lot, Johan. Well, first of all, thank you very much, Thomas and Nippe, for the invitation, for the warm welcome. Digital wood flow, at the example of Wisdom Stockholm, is the title of my speech. But before we start talking about the digital wood flow, I have to do a quite long introduction about the process we have been going through. And first of all, I want to explain to the audience who is Blumer Lehmann. Today, all of you heard several times Blumer Lehmann. So we are a company with three main departments. We have a sawmill. We have a production of wooden silos for salt logistics. And the biggest part of our company is the Blumer Lehmann AG. And we do all variations of building solution in timber, in wood. We are really driven in our own company to close the life circle of wood. So we have the sawmill. We make the products out of the sawmill. We use them to build the buildings, and we have our own power plant where we produce our own thermal and electric energy. So sustainability for us is something that we really live already today. We're located here in the east of Switzerland, our mother home, the heart of the company, but we also have different branches in Luxembourg, in Germany. Last year, we even started modular production of modular buildings in Germany. Katharina Lehmann, she's the CEO of the Lehmann company, and she really represents our passion for the wood in the 5th generation. She has no formation as a woods engineer, but she was grown up in the middle of the company. She was playing in the sawdust when she was a child, and that's something we feel she has really the passion for what we do with our fantastic material. That's the timeline, the flow of the project. About the initialization, difficult word, Johan already told you. I will go through different phases with you now, through a mock-up phase, contracting phase, and then let's say the execution phase, where we stack in now with the planning, production, and assembly. We are not alone. To make such difficult projects become real, you need a team of specialists. And from the beginning, we worked together with SJB, structural engineers, very skilled in calculating free-form structures, together with Hermann Blumer, who already was a partner for Johan in the development phase. And we had the company Design to Production, who are specialists in parametric planning, also on board from the beginning. Short explication how we normally are used to build freeform components. So we are used to produce blanks out of glulam. They could be straight, doubly curved, single curved. They are then milled on the CNC machine on all sides to obtain a very good accuracy and a good quality of the surface. Here you see the heart of our CNC center. With our CNC machine, we mill pieces with a length of up to 30 meters, 5.4 meters large, 1.8 high. And that's how it works. Here you see first mill outs for connectors, then the finished piece. In the background, you see the assembly, the pre-assembly phase, and then pieces are wrapped, brought on the building site, assembled, and maybe you already recognized the building is the Swatch headquarters in Biel that Johan already mentioned. It's the biggest freeform structure, grid scale structure we ever did. The building is even longer than 200 meters, a span up to 34 meters. Again, Shigeru Ban architects. Some impressions from the inside, again from the outside. But now we entered the Wisdom project, and the topic was to use fantastic material produced by Stora Enso. They really produce fantastic wood material, but they don't produce any curved beams. So we had to start thinking in new directions. So we entered a mock-up phase. We had to try how to do those structures or those beams out of LVL, of laminated veneer lumber. And we did a first experimental mock-up. So that's located at the top of the structure. Here you see an explosion drawing, and this was more or less fully designed by Hermann Blumer. So the idea was, here you see 4 layers of grid beam, and every beam consists of 4 lamellas, 39 millimeter thick LVL. For the connections, we used a quite traditional way to combine different wooden sections by using shear dowels, which are also made out of wood material. So you see here, there is always a cross connection and also a shear connection in between through crossing points, and it's all made in the same system. The workflow we planned for this was we will 3-axis milling the lamellas, which need to be curved when they are bent over the freeform surface. Then we need to mill a template on the CNC table. We will bend those pre-milled lamellas on this template. We will then mill the holes for dowel, install the dowel, and then remove the fixings on the template. The goal was that the pieces stay more or less in their form and stable. So that's what we did. Of course, we did some structural estimations, but we did not do too long studies in theory. We are craftsmen, so we need to have a look at how it works, and trial and error, and at the end you have a solution that works. So you see at the right picture on top, the milled template on the CNC table. Then in the big picture, you have the fixed lamellas on this template. At the right on the top, the installed dowels. And at the bottom at the right, you see what happened when we detached the pieces from the template. So we had big spring-back forces, spring-back movements. And in the big picture, you see how the mock-up then was assembled. It was not that easy because you had, again, to bend the pieces in the position. That's, let's say, the view of the visitor at the end. Of course, those screws and washers are not the final solution, but it needed to be executed in several times, so we didn't think about every detail. We did a second mock-up. That's what Johan already showed. But we also did some smaller samples in a small scale. Here you see Herman Blumer together with our production manager and also a craftsman. So they work already in this phase together. So we have experience, skills, knowledge from different sites. The same process, milling the template on the CNC table, pre-milled lamellas, bending on this template, milling the dowels. The problem, of course, was the same as with the first mock-up. And the learnings we did, well, of course, the high forces required to fix lamellas, caused by that, the big spring-back movement, spring-back forces. Then, of course, we have to start also thinking about efficiency, about costs, so we will have a high amount of material and process time just for those formwork pieces. And in the end, also an enormous process time on the 5-axis CNC machine to mill all these dowels, bend the pieces, install dowels, and so on. On the other side, the structural engineering found out that there is a 5th layer required, so that means even more pieces to produce. So the optimizations we did to be able to bend the pieces with less force, of course, we reduced the thickness of lamella. We work now with 31 millimeter LVL, which means that we need now 5 lamellas for each beam. So, point of view economic, that's not an optimization. But the big optimization we achieved by combining a little bit how we are used to build freeform with highly prefabricated pieces, and the examples you saw in Johan's presentation, where they bended the pieces on site in a certain form. So the idea then was that we just will bend and produce layer A in our shop, that we are just going to mill in a plane the lamellas, then glue it on a chip. We had to, or we have to glue them together to get a good template also for the montage with the first layer of grid beams. And to achieve with this concept, we had to develop other dowel systems which enables this procedure. So here is the first draft of the dowel system we use now. the dowels are not cut in two pieces, but the interface between dowels and lamellas now need to be designed for an on-site assembly. So the first dowels in layer A, which is prefabricated, are installed in the factory. All the rest, second or B, C, D, and E layer, then is brought on-site just as milled lamellas out of even motherboards. Somehow we had to come to a contract. So with the knowledge we had at this moment, you cannot really do a contract. So we had to again go deeper into detail, develop these connections a little bit further to get the knowledge which connectors we need around it. And very important in this concept now are the inclined side faces of the dowels. Because if you have dowels on the roof which are looking into different directions and you bend a lamella with pre-cutted hole over it, if the dowels are parallel, you can never assemble this. We thought about how to erect, how to assemble. So first of all, we have those columns. Of course, there is a temporary stabilization for them. We have then a ring beam, which gives a frame around the grid shell. Then we bring this layer A. Each beam is in 3 segments with a length of around 15 meters, which is really highly prefabricated in our factory. And then the rest of the layer comes on site as even lamellas, already bundled, 5 lamellas, who belong together as one beam. Then we have some shear panels. It's kind of a stiffener where the grid shell meets the columns. And at the end, the last layer of lamellas, again, bundled 5 lamellas, which are even brought on site and then bended over the connectors. In the end, we have cantilever beams. Each beam is also with a individual geometry due to the curvature of the roof and the cantilever panels. And with this knowledge, we created a kind of a contract. And that's what we have when I was here in Stockholm last time, beginning of December. And let's say what we felt when we came here was a little bit this motto. We never have tried this before, so we are completely sure that we can do it. It's a statement of a famous Swedish lady. Maybe someone of you already know her. No. Yesterday I learned she's called Pippi Långstrump in Swedish, isn't it? So here is an image of the groundbreaking ceremony. Here we already have been part of the team. Our concept was able to convenience the client. So you see Katarina here at the right-hand side. She has been part of the groundbreaking ceremony and of the Wisdom team. And now we enter the phase with the full collaboration with the planning, production, and assembly. And it's very important for us that we keep those 3 phases bundled. You cannot have one which which plans the geometry, another one which plans the structural engineering independent. You really need already the knowledge for the assembly, for the production, all possibilities when you start designing those connectors and all this stuff. What did we do? We did another mock-up. We've chosen the most complex corner with highest torsions, including such a shear panel connection to the column. And we did this detailed mock-up. This really pushed us far in this process. We already involved our production responsibles. We already involved some subcontractors, we worked with the Stora Enso material to get the feeling about their quality, the accuracy. The assembly of the mock-up was executed by a very skilled foreman, which is then also responsible for the assembly here in Stockholm. So everyone had the opportunity to make some experience with the structure and to implement his optimizations and his ideas. So here is a small short movie how we assembled this mock-up. It's quite big. It went not that fast, but it went even better than expected. The benefits of this mock-up was a lot of trust. On one hand side, a trust for us, for our people, that we can do it, that the production times are working, how we calculate it, but also a lot of trust from the client, from the partners in the project that we really can do it. And now, let's say, in all these previous phases, we distilled some knowledge. We worked to get to data which can be then implemented in the 3D model. At the heart of the process now, when we plan the execution, there is a parametric 3D data model, of course, which interacts with different stakeholders, with the architectures, with the production, with the structural analysis. And I want to quickly show you how such a parametric model is built. First of all, we have a master surface. Here, the master surface at the inside is the lowest, the bottom face of the first grid shell beams. Then you have a grid which is even, and the grid lines are projected on the master surface. Then we extrude truss surfaces. These surfaces at each point are standing normal on the master surface, so which means rectangular. If we zoom in a little bit, we have where those two faces, truss faces, meet. We have the blue line, which is then the axis for the cross connection. And then the other lines are then axis for the different grid beams. If we are talking about the parametric model, that means it's not a model which is fixed. So if we change now as a parameter maybe the grid distance, all other geometric devices in the model can move automatically. Then the grid beams, the axis or the cross sections of the grid beams are generated along their axis. And here is a graphic which shows a little bit how we work with this model. At the left side, you see, let's say, two loops. In the center, we have the parametric model. And also here, we are talking about an iterative process. That's what we heard today several times. So we have the parametric model, which takes a loop through the structural engineering. They do feasibility studies. They make variations. The information is transformed back into the parametric model. On the other loop, we have the architecture cut. There, the coordination with all other disciplines is made. So coordination with the interface to concrete works, to disciplines like ventilation, electric, and so on. Also, these informations then are implemented in the parametric model. And those loops, they need to turn several times to find really the final production geometry. And if we once have this geometry, this coordination model, we start extracting informations out of this model. And we start to step in further in detail, which means we have digital craftsmen in our company who start then feeding their information into the model and mostly working with informations coming out of the model. So in the parametric model, then the beam sections are divided into those different lamellas. It needs to be segmented. The length of the lamella is given by installation vectors due to this assembly possibility with our inclined dowels. And those lamellas then are exported to a nesting. They are all unrolled in an even plane. And here we generate the blanks, which are then ordered in that way. Nesting is always need to be organized in different nesting groups, because we also have to handle then a logistic. So we always have a nesting group including 5 beams. Here you see how the different lamellas then are optimized to avoid as much waste as possible. Here, this is an image of Stora Enso, how they then deliver the material. So every nesting group then is a package of raw panels. And sometimes we have different lengths, different surface qualities in one package. So it's really great how flexible they are to make this project become real. Next step is we need to export the fabrication data. So we ordered already all these blanks, but we don't have the detailed model now. We are still implementing all these connection details now. And there is another loop. So the nesting need to be connected with the parametric model. So every piece that is exported with the cutouts needs to find the same location in the blanks as it is already when we ordered the blanks. Another big challenge is we plan the geometry, the curved, in the final location, but we have to unroll all these pieces. If we would do all these cutouts in the curved situation and then unroll all these lamellas with the cutouts, all cutout surfaces become curved, and the process time on the CNC machine increases immense. So we work here with cutout volumes generated in the 3D model. The volumes are exported with the lamella, but they cut in the lamella after unrolling to have perfect, even cutting surfaces and an optimized process time. Then let's speak about the digital craftsmanship of the structural engineer, because what he does is also super fantastic. They have a model where really every lamella, every single shear dowel, every connection, even the holes from the dowels in the lamellas are implemented. I think a loop to calculate, and they have good computers, but a loop to calculate needs around 24 hours. And they also work with the parametrics. At the left side, you see a program called Rhinoceros or Rhino. That's where the parametric model is made in. And at the right side, you see it's kind of a graphic programming tool to generate some demands for the parametric model. Someone call it the spaghetti monster. So what does he do? We have on the column's head, for an example, those connectors. Here we have to work with steel connectors. And every connector on these columns have a different inclination, different rotation, so every piece is unique. But no one wants to go in and model a unique piece. So they are able to do a script in the Grasshopper tool. The script is referenced to the parametric model, and all these steel parts then are generated automatically. Then steel parts are exported to the program for structural analysis, where they can check stress in every detail. And also this, again, is an iterative process. So you first do a rough estimate, you model the piece, you double check structural the forces. Sometimes it works, sometimes they are overloaded, sometimes they are not really, they are too big, and then you have to do another loop. Every loop needs to be calculated for 24 hours. Last but not least, some facts, figures. So in the whole grid shell roof, we are talking about more than 2,700 individual segments of lamella that need to be produced, handled. Logistic is a big challenge. We have more than 20 kilometers of those LVL lamellas to produce. We have 1,740 such shear dowels and more than 1,800 conical dowels for the cross connection. All connections in the grid shell are really just wood-based connections. We have 520 cubes LVL for the grid shell, and in total it's about 750 meter cubes LVL that we are going to use to make Wisdom projects become real. So that was the history that we plan to realize here in Stockholm until December this year. And of course, we always like if you comment, share, follow us on social media.
A big hand, David. Time is running, and perhaps the intention was to have some kind of discussions, but I think it's important that we end up at 4 o'clock, as we said from the beginning. However, there must be some questions from the audience, perhaps from you watching on your screens as well, or you are just blown away. Any questions from the audience?
Yes, I wonder, this last project, my name is Camilla.
Kan du ta mick?
You don't hear me?
Men ta mick för sändningen.
Oh, sorry. Oh, God. Excuse me. Hi, my name is Camilla. Thank you for all the presentations today. But I just want to... Okay. Oh, my God. Okay. Yes, I was just wondering, because when you look at those dowels, they sort of seem to be the same sort of size. So I just wondered if you could describe what is standard and what is unique on this roof ceiling. I mean, about the components. Which are like standard components, or is everything different? I just wondered. When I was I couldn't sort that out.
I shortened a little bit the history about master surfaces and parametric model, but in real, the E layer, so the outermost layer, is not an offset of the first 4 layers. Towards the edge, the structure is getting thicker. And between this D and E layer in the grid shell, every connection dowel is really an individual element. But of course, those dowels, there we have repetitions. In the first 4 layers, we have some repetitions. We have different dowels, some for lower forces and for higher forces. So from these 1,800, maybe 800 pieces are individual, and the rest divided on I think, about 6 different types of dowels.
Other questions? Yes.
Yes, hello, Robert Jokva from Chalmers. I was wondering, we have seen a lot in the first block about the digitalization in the sawmill or in the forest and the sawmill, and now a lot of digitalization maybe in the manufacturing and on the construction side. So how can we connect block 1 and block 2? So the forest and the construction side.
A good question. I really like. Yeah, I was about to ask the same. The floor is yours.
I was wondering, I had the same question when I was listening to the first block. But somehow if we would try to work really with the data from the sawmill and from the wood industry, which means we would have to know in every lamella which kind of wood we have in this. I think you can imagine that the logistics, the sorting of pieces will increase in today, I would say it's impossible to treat all those different individual parts. So if already the raw material is unique, every raw piece is unique, it's more than the double work to be done to have the correct unique piece at the correct time in the production, and then the correct prefabricated piece on time in the right order on site. So it just adds a lot of work with logistics, sorting pieces, which is maybe today much more expensive than working with a little bit lower performance of the material.
To be continued. But I was also thinking, you showed us one picture with the 3-dimensional data information model being the heart of the process. And then you have the architecture, the structural engineering, and the production around the heart, so to speak. Of course, the heart is really the human beings that are working with the project. But how would you say that the digital tools can support this integration between different disciplines, between different parts in the process?
Well, of course, the most important resource that we need for such projects are the brains behind. The digital tools really can be used to avoid, let's say, stupid work. As you saw, we didn't need anyone who is turning all steel plates at each column. You just script it, and then you have an algorithm who is doing this stupid work. But very important is that brain work is done before. So someone has to generate the script, and you have to have a basic model which can handle this script. And of course, in the communication with all other disciplines, which is then organized in the architectural model. So that's maybe also what Anna showed to us. So
yes.
This is, let's call it the standard BIM process, which is in such a project done in the architect's model. Because if we would implement all this coordination also in our really detailed model, I think it would increase immense. As Anna said, to have production data out of such a model, you need a digital accuracy. You showed more or less rectangular structures. There you said it's quite a challenge for you. But you can imagine if you have these free-form surfaces, first thing that our specialists do is really to create an accurate master surface, because CNC machines, they work with the accuracy of 0.0001 millimeter, something like that.
And that tolerance is also the result in the factory?
Well, we are working with wood. From the beginning of this event, everyone mentioned that we are working with the natural biological material. And wood increases moisture, decreases moisture, so
absolutely,
it's absolutely not possible to say we are working with an accuracy of 0. Something millimeters.
But you are below 1 millimeter.
Of course we are.
Yes.
Even for these connections, the inclined dowels, load-bearing surfaces are planned with 0.0 millimeter tolerance.
Something to take with us. I was also thinking about the BIM and what you told us, Anna, about, and thinking about how, of course, it has to do with human beings, in what extent the collaboration works or not. But how would you say that digital tools like BIM can support this integration? Does it support the integration? I sometimes translate BIM, which is building information modeling, with building integrated modeling. Would you say, how would you describe the support from digital tools in this?
No. Ja. Ja, men den är på. I think it's our, I mean, it's the tool that we have. So we need to master it with a higher level of accuracy, I think, and also to if we sort of find the key in order to get all these, like, what is it, the in between us, like even though, I mean, we are using different softwares, different file types, whatever, but in the end it feels, if we learn to integrate the connection better in order to give, like, to handle the information better between parties, that's the key thing. And also, I mean, it's we think that BIM is not just about the digital model, it's also a way of working. So
exactly.
I think what we need to expand the way of looking at BIM. What is it? I mean, in the end, I think we need to describe the process connecting to who is responsible, like a person who's actually collecting information, taking responsibility for the information to go further and so on, to look at the accuracy and so on.
Would it be possible, Johan, you showed us some older examples of fascinating shells. Without computers, without digital tools, would this building, the Wisdom Dome, the Wisdom Stockholm building, would that be possible at all without this kind of digital methods, tools?
I think it would be possible, but in a completely different way of working. So what we do now is, let's say, a combination of prefabrication and on-site assembly. And if you would like to do it completely on-site, that would mean really a huge amount of time during the assembly. You even had to saw the pieces on site. That's a little bit a challenge we still have in those projects, because you always have other disciplines who think we can then come and bring our rectangular pieces and mount them between those surfaces. But you have nothing which is parallel, nothing which is even, and that's the case if you try to work in such geometries without using digital tools.
I think we need to round up, isn't it so? We have passed 1600, so I just want to thank you very much, Anna, Johan, and you, David, for this afternoon and very interesting presentations. A big hand, first of all. And then you are looking at me, Nippe, and you also want to, but we will give you a small gift and as a thank you for
Thanks
this
a lot.
Presentation today. And let's be in touch to see what happens with Wisdom Stockholm and other things. And for you, Anna.
Thank you.
And there you are. And now everyone comes here. It's like the Nobel Prize award. You know what? There you are. Yes. Go up so everyone can see you on the scene. And there you are. Go up. And I have one left.
Yeah.
And that is for you.
No,
or?
it's for you.
Okay. Thank you. Thank you. And thank all of you that have been listening, and I hope you are also blown away by these different presentations you have listened to during the afternoon.
Could I add an extra word?
Absolutely.
I think that I love the concept of Wisdom Stockholm, because looking back at the seminar, with wisdom comes with age. So my question for the future is, how can we learn from this experience, from this wisdom, to apply it, not to very unique architectural constructions, into the more younger, more mature, standardized things? Because I found when I visited you a few years ago, one of the fascinating things with the digitalization was that it was possible to digitally assemble on site and deliver each individual component just on time. So it was very efficient part there. How much can we from this project learn into the standard, mature, just standardized buildings? You don't have to answer now. This is to be continued. Thank you.
But that was really a question on my list as well. Thank you very much.